Hello class, today we are going to look at properties of kites. Yes, kite is a shape, and the shape of a kite looks like a kite. There it is. A kite is a quadrilateral with two sets of consecutive sides congruent, but opposite sides are not congruent. Okay, very important. Opposite sides will never be congruent in a kite. All right, we'll have two sets of congruent consecutive sides right next to each other or adjacent sides, but never opposite sides. All right, so opposite sides will never be congruent in a kite. Now, this does give us a couple of little theorems, a couple of things here. First off, in a kite, there will be exactly one pair of opposite angles congruent. Only one. Always one pair of opposite angles congruent, and that pair will always be the pair that is in between the non-congruent sides. All right, every time. So we have congruent sides here. This angle, not going to be congruent to the opposite angle. Here we have non-congruent sides, and so the angles between those non-congruent sides will be congruent to each other every time. All right. Only one set of opposite sides, opposite angles congruent, never both sets. A kite is not a parallelogram and will never be any kind of parallelogram. All right. Kites are not, rhombus is not a special case of a kite. No overlap. Okay, kite diagonals theorem. The diagonals of a kite are perpendicular, very much like a rhombus, but the opposite sides are not congruent, and therefore it will never be a rhombus. Even if I shortened this up, segment BD, and bring it in, if I make all four sides congruent, it stops being a kite. All right, very important. Now, a couple other things about the diagonals. Not only are they perpendicular, but there will be exactly one diagonal that gets bisected. All right, so here CA is bisected by BD. And the thing is, the diagonal that gets bisected will always be the diagonal that is between the non-congruent sides. So this is the diagonal that connects the congruent angles. All right. The diagonal that connects the congruent angles is the one that gets cut in half by the other diagonal. Okay. Other thing about diagonals, one of the diagonals will bisect opposite angles, right? And that will be the other diagonal. The diagonal between the congruent sides, the one that connects the non-congruent angles, will bisect those angles. Right? So segment BD bisects angle D, and segment BD also bisects angle B. Right? Divides those angles in half. And very important to remember that it is the non-congruent angles that are being bisected. The congruent angles are not bisected. Right? This angle here is smaller than that angle there. All right, so let's take a look at this. We want the measure of each angle in the kite. So I've got a 60-degree angle over at E, and angle H measures 110 degrees. One of the other angles, F and G, is going to be congruent to its opposite angle. So the question is, does G equal 60 degrees or does F equal 110? Well, if you remember, the congruent angles are between the non-congruent sides. So that would be right here, non-congruent. This side is not congruent to that side, right? And so these opposite angles are the ones that are congruent to each other. So angle F is going to measure 110 degrees. Now the question is, what about angle G? Well, I do know three angles now of this quadrilateral. The question is, what is that fourth one? Well, since it's quadrilateral, let's see here, I'm missing one. So if I know all but one, I can solve for that missing thing. All right, I can just add up the ones I know. So 110 for F, 60 for E, 110 for angle H, gives me a total of 280 degrees. The question is, how many degrees does it all total up to? All four. Well, it's quadrilateral, so that would be 360 degrees. So all I have to do is subtract 360 minus 280, and so angle G is going to be 80 degrees, and that way they all add up to 360. Notice again, E and G are not congruent. E is 60, G is 80. Okay, only one set of congruent opposite sides. One set of congruent opposite angles. Now, we have talked about a lot of quadrilaterals. Right? We have just quadrilaterals in general. Everything here is a quadrilateral. It all has four sides. And then after that, they are labeled basically generally by how many parallel sides do they have. Parallelograms have two sets of parallel sides, and there are some special cases of rectangles which are equiangular, rhombi which are equilateral, and then squares which are both. All right? If it only has one set of parallel sides, we call it a trapezoid. And there are special cases there. You have the isosceles trapezoids, which do have congruent diagonals like the rectangles do, but notice only one set of parallel sides. So rectangles and trapezoids, there's no overlap. Okay, rectangles are parallelograms, they are never trapezoids. And then you have shapes that have no parallel sides, which is these just random quadrilaterals out here, which are actually called trapeziums, which you don't need to know that. That just means they have no congruence, no parallel sides that are, and a special case of that would be the kite, which, notice, no parallel sides in a kite, but it does have two sets of congruent sides. And remember, it's always the sides that are adjacent to each other, not opposite each other. So what I want to look at real quickly, I want to give the most specific name for these quadrilaterals. Notice they are not drawn to scale. All of these look like rectangles, but that doesn't mean they are. So let's take a look at this first one. What do we have? We have the diagonal is bisecting each other, right? Because this is the same as that one, this one's the same as that one. So since it's both diagonals, that makes it a parallelogram. If there's only one, then we could probably say it's maybe we could say it's a kite. But both sets, so that's definitely a parallelogram. It does have perpendicular diagonals like a kite, but again, it's a parallelogram. So let's see, with a perpendicular diagonals, that would make it a rhombus. But notice the diagonals are all congruent to each other, which makes it a rectangle. So if it's both a rhombus and a rectangle, right there in the middle we have squares. So this first one, that's a square. Doesn't look like a square, but hey, not drawn to scale. You go by the markings, not by how it looks. Judge it by the content of its character, not the shape of its sides. I guess, whatever. Anyways, so over here we have, again, perpendicular diagonals, so possibly a rhombus, but we have only one diagonal getting bisected. The other diagonal, it doesn't show it getting bisected. So what do we have if only one diagonal is bisected and we have perpendicular diagonals? Well, that would be a kite. Kite. Perpendicular diagonals and exactly one diagonal gets bisected. That's a kite. Okay, let's see. M and OP, we've got one set of parallel sides, so only one set of parallel sides. That's all we got, so we're going to have to say that is a trapezoid. Doesn't have two parallel sides. If it had two sets of parallel sides, then we'd say parallelogram. But as it is, with only one set of parallel sides, trapezoid. Okay, last one. DEFC. What do we got here? We got one set of opposite sides parallel. Now let's see. Sorry, not parallel. One set of opposite sides is congruent. So that could be an isosceles trapezoid, except notice here we have one set, a diagonal is getting bisected. Okay. Well, if a diagonal is getting bisected, that would be like a kite, but you can't have a kite with opposite sides parallel. So diagonals getting bisected with opposite sides parallel, then what we're going to say here that it is a parallelogram, right? Because we have opposite sides congruent and a bisected diagonal, we're going to have to go parallelogram. Can we go more specific and say rectangle? No, because we don't know the diagonals are congruent. We don't know that we have right angles. Can we say rhombus? No, because we don't know that the diagonals are perpendicular. So, and we don't know if DC is congruent to EF. So we can't say a rhombus either. All we know is that it is definitely a parallelogram, but that's all we got. All right. So when you're trying to tell which kind of quadrilateral is, you got to look at everything. Start with how many sides are parallel, and just narrow it down as much as you can. So for example, here we've got one diagonal bisected, that could be a kite, it could be any parallelogram. The perpendicular there, so it's only one, so that's a kite. If we'd had two, we'd say rhombus. Here, opposite sides are congruent, so it can't be a kite, it's got to be the parallelogram. All right. This one goes all the way down to square. So just to refresh, in a kite, you have one diagonal bisected. The diagonals are perpendicular. The diagonal that is between the non-congruent sides is bisected. This will not always be the short one. Sorry. The diagonal that is not bisected does bisect the angles, but only one of them bisects angles. And you do have one set of congruent angles. Very important in kite to remember, opposite sides are never congruent. Not congruent. All right. And there you go. Hopefully you found that useful, and I will see you in the next video.